All right, so we're going to do over some of the worksheet problems. We're going to do definitely number one and go on from there. So number one, ABC, it's asking us to find the volume of a couple of solids bounded between these 2 points, or these two curves. Y equals x plus 1, which is actually a straight line, and y equals x squared minus 1. And what I'm going to do is just show my browser to show the Desmo graph. Now the Desmo graph should show us where those intercepts are. So it should feel familiar to the finding the area. We need to know where they hit each other. So we know for a fact our bounds is going to be between -1 and 2. So it's going to be -1 and 2. And it's still important to know which one's on top and which one's on bottom. Desmo's color coded, so it seems like red, which is the x plus 1, is on top, while the green x squared minus 1 is on bottom. So let's first set that up on our whiteboard. So I'm going to go back to the whiteboard. And so let's set up the integral. So the integral is from -1 to 2. The top equation is x plus 1. So I'm going to put x plus 1 minus the bottom equation, which is x squared minus 1 dx. So then we could just simplify this. So we're going to have negative x squared plus x plus 2. Okay, from 2 to -1 dx. Okay, so if we were just finding the area, we would just integrate this and solve it. Now we're trying to do what is finding the volumes, which is 3D shapes. So depending on what shape or cross-section shape we're going to use is how our formula is going to change. But this right here in the yellow is, we could call it our base, because this is always going to be the base of whatever volume we're going to use. So this is the base for particularly question number one. Okay, so I'm going to look at part A. So before all these questions, you want to figure out what your base is before you continue. So for part A, it says, what if the volumes were squares? So if there were squares, so just to redraw this, kind of like, let's see, instead of that, let's draw it a little bit more skewed. If you watch the Khan Academy video, he draws it a lot better than me. But there's this, like, we're going to make little squares that are like coming out of the 3D shape. They're coming out of the 3D panel, essentially. So your base, which is the between the two curves that we have here, again, the colors enter. I'm not going to be as good as a drawer. I'm not using a draw pad like the guy is.
Wait, Mr. T, which
I posted a
practice
new
sheet are you
worksheet.
looking at?
I
Which
posted
worksheet?
a new worksheet. It'll be, the first thing will be calculus worksheet on volume by cross sections in caps. So get on that one. I reposted it, so it should be.
Oh, so it's not the one from earlier today?
No, that one earlier today is for something we call dish washer method. What we haven't learned that yet.
So I can throw this sheet out?
We're going to use it later, so if you already printed out, I wouldn't waste the ink. Okay. Right. We just haven't learned the method for that worksheet yet. Okay.
So we're learning cross sections right now.
This is called cross sections.
Oh, okay. So I got to print this one out. I'll be back in a sec.
Sure. But I'll still continue. So if it's a square, that means the base of the shape is also going to be the height of the shape. So what I could do is, with this one, is rewrite this equation. Since I know the base, and the reason we have to keep it an equation is because depending on where you are, it's going to be a small gap or a big gap, depending on where you are in the curve. So you want all the squares between -1 and 2. So the volume of this shape is just going to be whatever the area is squared. So for A, and I'll do it in red, for A, it's simply going to be the integral from 2 to -1. And then I'm going to put parentheses here. Negative x squared plus x plus 2 squared dx squared dx. And this little square that's coming out of the parentheses is because it's like 3D now. We're timesing the base, which was the original area in yellow, times the new height, which is going to be the same size because the base and the height is the same. So it's this times that. Now, we could use U substitution. You could FOIL it out if you want to. I want to also show you how to do on the calculator. The YouTube tutorial is pretty good that I posted, but I'll just show it with a TI-83. So let's see if I can share that.
Oh, what's this?
Okay. So what this is going to do is how you do it on a calculator, okay? Now my thing, if you have the like 84, it's going to look like you draw the integral, so it's a lot easier. But my thing kind of sucks, so I'm going to show you the old way, I guess. So I'm going to click math. This is still the same for everybody. I'm going to click math, and you could click number 9, but it's going to be option 9, FN integral, or from F to N integral. So I'm going to click enter. Now mine's look like this, where I'm going to have to type it in, comma, type it in, comma.
Mr.
Or
T,
it's going to look like an integral, which is really nice.
Mr. Tobel, the short video that you sent, the
Yeah.
one where he was explaining like the 3D image at the end, he had a good one for the TI-84.
Yeah, so like I'm just showing it one more time though, just so we can apply it to this question. And then from there, I'll just use the answer sheet because I'm going to trust that you're going to learn how to plug it into the calculator. But if you just happen to have a TI-83 version, this is real quick. For the TI-83 version, what you do is you first put your equation. So that's going to be, and I'm going to put it in parentheses again, negative x squared plus x plus 2, close parentheses, and that whole thing was squared, which is what I wrote on the whiteboard. I put a comma. It's going to, then they ask you what you're deriving by. So, or what's the dx? Is it dx, dy, dt? It's x, so I'm going to put x. And then your lower and upper bound. So that's -1, and that should be 2. Close all of that, enter. I'll get 8.1. Now, you could do it by hand and get 8.1. You could do it by calculator and get 8.1. I recommend doing the calculator. We already tested on U substitution, integral by parts. I'm going to trust you know how to do that. So you could use the calculator from now on. All right? So the most of your question here is just a setup. Nava, go ahead.
How do you square it? Because on this calculator, you just fill it in, but it doesn't allow you to square it, I don't think.
Probably have your cursor at the last parenthesis you wrote.
It skips it. It goes right to the...
Nava, put in an extra parentheses at the beginning and at the end, and then in between the last 2 parentheses, you could put the square.
Okay.
Do you know how to do this with a Casio?
Casio, I don't know.
No one
Casio.
uses a Casio.
I'll try to look it up, but I do not know offhand. I'm sorry, Max.
Right. Well, I would have to do it by hand then if I can't find out, right?
That I'll try to post this virtual calculator later on, and hopefully I could just send you a download link or something. Okay.
Oh, okay. And thanks, Nom. I think it worked.
Okay. So you should get 8.1. If you don't get 8.1, we'll work on the calculator thingy later. So we're gonna go back. We're gonna do B now. B. Let's see. Oh, thank God I saved. So B, it's now the 3D shape is a rectangle with a height of 1. Okay. So it's a rectangle with a height of 1. Remember, this equation right here is your base. This equation right here is your base. So the area for a rectangle, oh crap, the area for a rectangle is base times height. So this is the base, which is negative x squared plus x plus 2 times Now, it just said the area of the rectangle is 1. So it's really easy. It's just times 1. Because it's times 1, it doesn't even change anything. It turns out to be the same as the area equation. So we times it. So this is your base. So little b for base. And this is your height. And dx. You could type that into your calculator. You don't need to type the 1 in this case because this is times 1. And then for this one, it should be, and I assume you type in your calculator and all that, 4.5. I'm just looking at the answer sheet for the final result. Let's see if I can do this. So rectangle with a height of 1 turns out to be really simple. You don't even do anything special to it. Okay, next one is the equilateral triangle. So what does that mean? So when I say any shape, the base is always the distance between the two curves. So let's think of this, and I'm going to call this whole equation u to make it a little easier, so I don't have to write so much. Okay. So we have an equilateral triangle. An equilateral triangle, if you don't remember, is a triangle where all the sides are equal. So if this is u, this is also u, and this is also u. Okay. But we need to find the area of the triangle. So every time we need to find the area of the triangle, we need its base and height. And from this situation, I can't tell the base and height. But if I cut it into half and make this a right triangle, I know this piece right here is going to be u over 2. Also, you got to remember, equilateral triangle is going to have 60 degrees, right? So this will be 60. And then over here is going to be 30. So now we have a 30, 60, 90. If this is 30, which is u over 2, then this over here is going to be u over 2 times root 3. So this over here, or the height of your triangle, is going to be root 3 u over 2. So the height of your triangle is root 3 u over 2. The base of your whole triangle, though, don't forget, is not u over 2. It is half, or it's just u. I'm sorry. Okay. So root 3 u over 2. This is base of u. So if we were to find the area of this triangle, it would be base times height divided by 2, or 1/2 base times height. So 1/2 times the base, which is u, times the height, which is root 3 u over 2. Make that a little simpler. That's going to be root 3 u over 4. So this right here, this blue, what I'm squaring right now, is the equation for the area of this equilateral triangle. Now, we can't plug in a number for u because the distance changes depending on where you are in the graph. It gets wider in some parts, it gets skinnier in some parts.
Mr. Tobel, wouldn't that be u squared?
Yeah, it should be, oh, sorry, u squared. Thank you. I saw this too. I was thinking I already wrote the square. So thank you, Joseph. So this is the area for that triangle. So we're just going to apply this here, and instead of writing u, we're just going to write this equation. Now, root 3 over 4 is a constant. So because it's a constant, I could just put it in front of my integral. So I'm going to write that, root 3 over 4, from -1 to 2. So most of your work here is not actually integrating, it's just setting it up and figuring out what shape or how do you find the volume. Negative x squared plus x plus 2. Remember, it's u squared, so this whole equation squared, dx.
And then you could just plug that into the calculator.
Then you could just plug that into the calculator. Probably type in root 3 over 4 first, and then click math 9. And then you do all that stuff. I'm just going to check the answer sheet.
Don't we already know that
The answer sheet seems to agree. But go ahead, was it Jared who was talking? Yeah.
I said we already know the inside from the first one.
Exactly. So you could just do √4/3 times 8.1.
8.1, yeah.
So it's on the answer sheet. I'll just write it here. They give you 3.529. If I were doing it by hand, I probably would just leave it with radical 3. So 81√3/40. And they probably, if you wanted to do 8.1, that's fine. Okay, so that's number 1. Any questions in general? If not, I'm going to clear this, and then I'm going to start number 2. Okay, I'll leave it up while I look at number 2 for a second. Squared plus y squared equals 4. Okay. So let's just graph it real quick. So I'm going to go back to the Desmos. We're doing number 2 now. And it's told you it's a circle where x squared plus y squared equals 4. And remember, if it's the square root of this number is your radius. So your radius is 2. So because usually our circles, when we make the cross section, is vertical unless otherwise stated. So they're vertical cross sections. See if I can note that right now. They're vertical cross sections, like better than that. But so our bounds for this circle is going to be from -2 to 2, because it starts at -2 over here. It starts at -2 over here and goes to +2 over there. Okay, so our bound is from -2 to 2, and I'm going back to the whiteboard. So we're going to start this off. So we're going to start this off by doing our integral from -2 to 2. So integral of -2 to 2. So integral from -2 to 2. And then remember, it's a circle, so we want the area of a circle.
So we don't need to find the base for this because it's a circle?
Yes, because the volume is like a prism coming out of the circle, like it's popping out of like a pop-up book. So we need all the circle.
Oh, okay.
So in this case, it's going to be from -2 to 2, the area of the circle. So what's the volume for the area of the circle? Well, it's
Pi r squared.
pi r squared. So pi r squared. In this case, though, we know r is going to be 2. So r squared is 4. So the area of the circle is 4 pi. I just want to check something, though. I don't know if we're going to put the area formula itself, or should we just be putting the equation itself? Oh. But remember, we're trying to integrate it from respect of y. So right now the equation is like this: x squared minus y squared equals 4. So when we plug it into integral, we want to have it equal y. So I'm going to subtract x squared on both sides. So I got -y squared equals 4 minus x squared divided by negative. So x squared minus 4.
I thought it was x squared plus y squared.
Was it plus? No, my bad. So plus. So this one is not important. And then we're going to have to square root both sides, I believe. Yeah. So we're going to square root both sides. So that is, so y equals the square root of 4 minus x squared. So what we're going to put in here is this when it equals y. So square root of 4 minus x squared. And we do have to be careful because technically some of this is not actually a function because it doesn't function the correct way. It's only a function from the positive side. So we just have to keep that in mind. I don't think that changes our math, but just saying. Okay, so this right here is our base. Okay. So let's do our shapes from A to seems to D. First one are squares. So squares are going to be, we're just going to square this. So for A, our equation is just going to square the square root, which will be canceled. So our first equation should be -2 to 2, 4 minus x squared dx. Why is there a 4 on those?
Just square it.
Yeah, you're supposed to just square it. I'm looking at
Oh.
the answer sheet though. It has a 4 on the outside. I'm trying to figure out why. Where's that 4 coming from?
Is it because the 4 is a constant?
Yeah, so where's the constant come? Oh. Okay. So I did mention this and it does actually affect the base. So we're going to change the base a little bit. Remember, square root of 4 minus x squared
Is
is
the
only a
half.
function from above the x-axis, right? Because as soon as you plug in or you're going to plug in something that causes to be what is it, imaginary. So I think what you have to do is times this by 2. The reason is because you're taking the area of the top and the area of the bottom. Does that make sense? Because you're taking the area of the top curve, which is the only functioning part, because you can't have two y's at the same time, right? So you're taking the area of the top part. Or if we're talking about the circle, it's the top half of the circle. And we're doubling it because we got to take the area of the bottom part. So your base should have a 2 here. And you could put the 2 out here if you wish. That doesn't really matter which one you put it in. But when you square everything, this also gets squared. So this is 4 minus 4x times 4. And then they move the 4 here. And that's where that 4 is coming from. -2, 2, 4 minus x squared dx. So finally, we got our final answer. Type that in your calculator. You should get 128/3. That's for A. Okay. Okay, and now we're going to go for B. Now, from B, we can use our information that we learned from, I think it was 1C, because we're looking for equilateral triangles. So we could use the information we had from B and use it again, because we know the area of an equilateral triangle should be √3 u squared over 4. Okay? So the u, the reason I used u is because you could plug in any function into u. So now I'm going to just replug this in for B. This 4, well, I'll just do it like this first. 2, -2. Is it 4 or is it 2 though? Where's the 4 on this one? Oh, because u is, so this is also getting squared again. The original 2 is getting squared again. So it's 4 minus x squared, close parentheses. Remember that square root got canceled out from the square here, times √3 over 4. These 4's cancel out. The √3 is a constant, so you can put that in front. √3 integral -2 to 2 and parentheses 4 minus x squared dx. So we set it up, and from the answer sheet, it seems to be correct. Your answer should be 32 root 3 over 3. Okay. So now we're dealing with a new shape, semicircles. Okay. So we're trying to figure out how are we going to work with this semicircle. So let's look at this carefully. So we know the base is going to be our the space of the curve, our integral. So we're going to, and I'll do this in some lavender color. We're going to think about how do we find the area of this. Oh, that's an ugly semicircle. Let me try it. How are we going to find the area of the semicircle using U as your base? Well, U in this case is the whole diameter. Because if it's a semicircle, then we have to make sure it's all uniform distance, which makes the radius U over 2. And for the area of a circle, it's going to be pi r squared. So that's going to be pi times U over 2 squared. And U over 2 squared, I could just rewrite that as pi over 4U squared. But it's a semicircle, right? So it's not going to be the whole circle. This is for the whole circle. So I have to do times it by a half. So I believe it should be at eighth on the bottom. And it seems like it makes out, yeah. So it should be an eighth on the bottom. So your formula, if you're using a semicircle, because it'd be pi over 8 U squared. And remember, U could be substituted for any function. Or, yeah, for whatever functions we're using in this case. Okay, so this whole thing right here is U. Not the squared part, just there you go. So this whole thing is U. So we're going to draw our integral again. -2 to 2. This is getting squared. So again, it's 4 times 4 minus x squared times pi divided by 8. I reduce this 4 into a 1. I reduce this 8 to a 2. Pi is a constant, so we can move that out. 2 is a constant, so we can move that out. So we're left with pi over 2. Integral -2 to 2. 4 minus x squared dx. I'm going to check the answer sheet if I set it up correctly. Seems like it did. Type in your calculator. 16 pi over 3 should be your answer. Okay. All right. So let's see. We got one more side. Oh, we got one more shape for this. So D is going to be the isosceles triangles where the base or our integral is the hypotenuse. So I'm going to erase the red and the blue. Does anyone else need that right now? That's kind of old, and I think it's kind of straightforward, all things considering. Okay. So, and I'll delete the stuff that helped us find the base. I'm going to delete that. Oh, come here. Okay. So let's see, orange. So we're going to do the last one, D. Now it's an isosceles triangle. Basically, that is hypotenuse on the ground. So our base is still our function, our integral. So our base is U. and it's a isosceles triangle. So if you remember isosceles triangles, every triangle has to be 360. I'm sorry, it's an isosceles triangle, which is a right angle. Yeah, isosceles triangle with a hypotenuse base as a solid. Okay, so this is going to be a right angle, and this is going to be 45, 45. So we're stuck with the same situation from before, which is we need to find the height, which allows us to find the area. So I'm going to cut this in half into another isosceles triangle. So this is u over 2 now. And then this is a 45, 45, 90. So this is u over 2, and this is also u over 2. Yeah, I can do it like that. So u over 2 and u over 2. So the area of this smaller right triangle is half base times height. So 1/2 times the base, which is u over 2, times the height, which is u over 2. But don't forget, this is only for half of the triangle. So we're going to times this whole thing by 2 anyway. So this cancels out and this cancels out. So I get u squared over 4. And the reason I'm a little confused because I felt like did I do that correctly? Looks like a workout. Yeah. Okay. I have to trust myself. So the
Wait, why
area,
did we multiply it by 2?
yes, and I did that
So-
up here though, so I canceled those out.
Why did you multiply by 2?
Oh, how I set it up, I cut it in half. You notice this? Like
Yeah,
so then 2 parts, so I need to double it because then it'll count for the whole
got it.
triangle. So this is our area for this situation, which is a isosceles right triangle. Now it doesn't say it's a right triangle, but there's a rule called, oh, I forgot the guy's name. But if you slide it over here, or if you slide it over here, if the base is the same and the height is still the same, then it's still going to cause be the same height. And the only way it could be isosceles and be uniform in height is a right triangle. So this is u squared over 4. All right, and remember, u could be replaced for anything. So this whole thing, again, is getting squared. So it's integral of -2 to 2. 4 root, not root, I'm sorry. 4 root, parenthesis, because it's getting squared, so the root is getting canceled out. Which is really nice because everything we've done here, it canceled out the square root. So we never had to actually deal with it. All over this 4 over here. dx. Seems like the 4's cancel out. So instead of rewriting, I'm just going to delete the 4's. The 4's cancel out. Actually, I should rewrite it because you guys have to rewrite it. So your final integral is 2 -2. This time now it's just literally what's inside the square root only, which is 4 minus x squared dx. Let me just check the answer sheet. Hey, it matches. I'm pretty happy with that. Type in your calculator, make the magic there. I'm going to leave this up for a couple seconds as I look into the next question. If anyone has an answer, just unmute your mic and then ask it. All right. I'm graphing the next equation now, so we have a visualization of it. Okay. All right, so I'll share it back to my decimals. So we have this graph right here, and you notice it's slightly different because they specify that it's y equals 0. So it's really good to know is that y equals 0 is the x-axis anyway. But it has to specify that because if not, you will be taking the area of everything below here in that negative x-axis. If you didn't specify that, or you didn't specify it's bounded by the x-axis. So we want the area between here and here. So we got to look at those interceptions again, or the intersections, my bad. So it's going to be the integral from 0 to 1, because all these intersect at 0 and all these intersect at 1. And I think when we did the volume from, or the area from before, sometimes they would like swap places. But this curve, this blue curve, which is x cubed, is always on top. So we only need one integral in this sense. So now let's start crafting our base. And we know our bounds is going to be from 0 to 1. So I wish there was a, oh, here it is. Clear out tracks. All right. So from the bounds of 0 to 1, the top integral is x root 3, or I'm sorry, x to the third power. And the bottom integral is simply y equals 0. So it should be minus 0 dx. Well, since it's minus 0, all I know is it's going to be the integral from 0 to 1 of x cubed dx. So we have a very simple base in this one. Okay. Now we have the base, we're able to solve everything we need to solve. So let's go through the problems. Okay. Following each cross section. First one squared. Now the area, the formula for a square is u squared. So I'm just going to square this. So 0 to 1, x to the 6th power dx. Because I did x to the 3rd power squared. So it's x to the 6th power. And this one I even could do by hand. X to the 7 over 7 from 0 to 1, 1 to 0. So it's going to be 1 over 7. Let me check the answer sheet. And the problem with the screen share thing is that every time you try to touch your tab in your browser, it pops up. But for some reason it's showing me something completely different. What did I mess up in? Let's see. The base of the bounded is all this. Find a solid for each of the following cross section, taken perpendicular to the y-axis. Okay. All right. So our question changed a little bit. The first two problems are perpendicular to the x-axis, which means you take y cross sections like this, which means we just do your normal integrals based off of x. But if we're taking cross sections perpendicular to the y-axis, we're taking horizontal integrals in this case. And the problem with that is that now we have to make sure our functions are inversed. So we're going to have to redo this a little bit. I'm going to go back to our graph and I'm going to annotate to show how this is slightly different. Okay. So in the previous ones, we would take the verticals like this and we'd be pretty happy. And that would be a normal integral. But now it's asking us to do our cross sections like this. So how does that change? Well, now the top and the bottom isn't x cubed and the y-axis here. The top and bottom is going this way. So it's going x cubed and this line, which is x equals 1. So how does that change? Effectively, what's going to happen is that now we have to think about our bounds again from 0, 1, but this time this space right here. Between 0 and 1 here. So how do we handle that? Is that we're going to have to inverse some of our equations. So let's go back to the whiteboard. So we're going to have to inverse this blue curve, which is x cubed. And then x equals 1 is a flat line, which will be our new line over here. So it's going to be slightly, so we don't really need to inverse that one. So let's go back to our whiteboard. Let's get to work here. So if I was told you to do vertical sections or something perpendicular to x-axis, our answer would be correct. But since it's perpendicular to y-axis, we have to do it slightly different. So the first equation we have to integral differently is y, or inverse, is y equals x cubed. Yikes. Y equals x cubed. So to inverse it, we have to make it equal x. You could just cube root it, but technically you're supposed to swap the positions first and then cube root it. So then cube root of x equals y. Wait. And I think it wants us to do it in terms of y though. Okay, so it's going to make us do it in terms of y. So we actually do just want to cube root it. So let me erase this. And again, I apologize for the little bit of the mix up. Usually I would be a little bit more on top of it, but you know, long break. Made my brain a little soft, I guess. So we're going to go cube root it. So now it's going to be in respect of x. So it equals x here. And then we're going to look at the other one, which was x equals 1. And thankfully, that's already equals x. Okay. So with that in mind, we're going to have to graph it. Or now it's different because before it was between the x-axis, which was really easy. That was considered 0. Now it's between this vertical x line and the curve. So because of that, we're going to have to rewrite it a little differently. So it's going to still be the integral 0 and 1. And I should say it's still the integral 0 and 1 because the points of intersections of the y-axis is 0 and 1. It just happened to be 0, 0 and happened to be 1, 1. That's not always the same. You have to look at the y's in this case. Before we look at the x for the intercepts, now we're looking at where they intersect at the y's. They happen to be the same in this one. Okay, so from 0, 1, when you rotate it, you have to rotate it across the x equals y line. So it's inverted like that. So the top part, I believe, is going to be the 1. So it's going to be 1 minus root 3y dx. So this right here is now our actual base because it's not dx, which I just wrote here. It's going to be of dy. So dy. Okay. So that turns our question, it literally turns the question on its head because now we're not looking at from up and down, we're looking at from left to right. So it's 1 minus the cube root of y dy. That should be our curve. So now we could really start. Now I could actually start this. So the first shape seems to be a square. Now the area of a square is u squared. So for A is simply going to be from 1 to 0, 1 minus cube root of y This is going to be squared dy. Okay. Yay. And you can do it by hand. If not, it doesn't matter. Turns out to be 0.1. Okay. So let's do B now. B is a different shape, and let me look at the question on the worksheet. So B is asking semicircles. So we're going to use that equation from last time, which I believe was u pi r squared. So u squared pi, but we're using half of the u, so it's 4. So pi u squared over 4. Okay, and remember this bases are u in this case. So again, 1 minus cube root y squared, close parenthesis. No, I'm sorry. Close parenthesis squared times pi over 4.
Would it be 4 or 8?
Was it 8 last time or was it 4 last time?
I think it was 8, but let me double check.
Yeah. Root 2 is 4 power squared.
It was 8 because it was pi u squared over 4, but then we divided it by 2 for the semicircle.
Thank you. That's true. So it's supposed to be 8. My fault. Just a note, these equations should be consistent within no matter what the base is, because the u is what changes in the base, but the pi over 8 doesn't change. So this is still 8, which means this is also 8. What a sad looking 8. From 1, 0, dy. This camera's over here, dy. And again, pi and 8 are constants, so we can move that out. Pi over 8, 1, 0, 1 minus cube root y squared dy. Let's check real quick. Okay, it matches our answer sheet. And then I think our last one is equal lateral triangles. So you could refer back to a previous section. I forgot which question was from the past, but that should be root 3 u squared over 4, if I'm doing it off the top in my head correctly. Root 3 u squared over 4. Could someone give me a confirmation or a deny? I think that's correct. I don't want to solve it again.
Yeah.
Okay, thank you. All right, so then plug in u, write the integral, move out the constants. Your final setup is root 3 over 4. The integral is 0, 1. 1 minus cube root y squared dy. Okay, so I just want to point out again, these equations happen to be always the same. The reason I kind of taught it like we found the equation, it's just so you could understand it. And like even me, if I forgot, like I forgot is root 4, if I took my time, I would be like, oh yeah, it's a semicircle, I have to divide it by 2. But sometimes you just forget the equation offhand, so you could always find it by hand later. So any of the work you just wrote down this, just take a picture, post it on the Google Classroom, that's fine. Again, I don't know if it's school policy, but I was told I can't make homework due the same day. So it will be due the next time we have class, which I believe is Wednesday. So if you feel like you need to ask me more questions, I'll be on. But otherwise, I hope this really helped out going through every problem here.
It did. Thank you.
Thank you.
Thank you.
Problem. No problem. No
Thank
problem.
you.
No problem. Mila, you got this all? I didn't. No, she got it. All right. Max, I'll try to look up on YouTube and try to teach myself Casino, but Casio. But
Yeah.
Offhand, I don't. I have no clue.
Yeah, there's no problem.
Okay.
Yeah.
All right, peace. Mike, any questions, or are you good? You want me to go back anything? I know you had to step out for a printer. Okay. All right, I hope this helped, and use this to your advantage. You can always check back to this video if you need help.